Welcome to QHSE Talks, the world's largest QHSE audio knowledge hub. Subscribe and be part of the movement.
Welcome back to QHSE Talks, where we turn complex safety, environmental, and sustainability concepts into real-world understanding that actually matters. Today, we're unpacking a topic that might sound technical at first, but once you see its real impact, you'll realize it's one of the most powerful tools in environmental management: environmental monitoring. Because this isn't just about collecting samples or reporting numbers. It's about seeing the invisible, the changes happening in our air, water, and soil long before they become a crisis. It's about how organizations transform raw data into awareness, awareness into informed action, and action into real, measurable environmental change. Think about it. Every environmental decision, whether it's reducing emissions, improving water quality, or managing waste, starts with monitoring. Without it, we're flying blind. But with it, industries gain a kind of environmental intelligence, a way to predict, prevent, and protect. And that's where self-monitoring systems, or SMS, come in. They take environmental monitoring to the next level, making it structured, consistent, and proactive. These systems turn compliance from a box to tick into a culture of responsibility and leadership. What's fascinating is that the process follows a clear evolution from simple observation to data, to information, to knowledge, and ultimately to wisdom. That's not just science, that's strategy. It's how smart organizations build foresight, act smarter, and protect the environment before the damage happens. So, if you've ever asked how we can move from reacting to preventing, this episode will show you what that shift really looks like in action. It's where science meets responsibility and data becomes foresight.
And what's striking is the depth, like you said. The source gives us, well, not just one definition, but several that fit together. And there's this clear hierarchy for data, how you get from a number to actual wisdom, they call it.
Wisdom, huh? Okay.
Yeah. And practical checklists for making it work in an organization. It feels like a guide to institutional foresight. Thinking ahead.
Okay, let's start with those definitions then, because the wording feels quite specific. There are two main ones here.
There are. The first one zeroes in on the physical action. It says EM is the systematic sampling of the environment. So air, water, soil, and living things, biota.
Systematic being the key word there.
Exactly. It's not random. And its purpose, to observe, study, and ultimately to derive knowledge. It's about consistency, having a clear goal.
Okay. And the second definition, it seems broader.
It is. It shifts focus a bit towards management communication. It says EM involves gathering, assessing, and reporting environmental info. And crucially, this info has to come from continuous or periodic sampling, observation, analysis, not just a one-off check.
Continuous or periodic.
Right.
So what are we actually analyzing for?
Good question. The source points to two really critical targets. First, just tracking natural variation or changes.
Right.
You know, the planet has its own rhythms.
Baseline stuff.
Yeah, baseline. But second, and this is often the trickier part, tracking anthropogenic pressures, the impacts from human activity, and the effects of those impacts, both on us, on people, and on the environment itself.
That distinction sounds challenging. How do you reliably tell the difference?
Well, that's the core challenge, isn't it? You have to filter out the background noise of nature from the noise we're making. If you're measuring, say, acidity in a river, is that spike because of normal seasonal runoff, or is it because of an industrial pipe upstream? You need the monitoring system to help figure that out.
Makes sense. And practically, where does this EM data end up being used?
Well, it's fundamental for just characterizing environmental quality.
Yeah.
But a huge application is in preparing environmental impact assessments, EIAs.
Okay, but let me ask this. If the company proposing the project is the one paying for the EM data, for that EIA, isn't there a potential conflict there? How do you ensure the data isn't, slanted?
That's a really important point. And it comes back to the rigor of the whole system, the SMS we'll talk about later.
Yeah.
Especially the part about quality assurance and control. The EM data, regardless of who pays, has to be defensible, auditable.
Right.
And the sources stress that EM kicks in whenever human activities carry a real risk of harmful effects.
Yeah.
So it's not just a planning tool for an EIA. The minute a project starts, it becomes a critical tool for mitigation, for managing those risks.
And the moment they break ground, monitoring becomes like an insurance policy. Okay, let's dig into the why then, the objectives. There are 9 drivers listed. Maybe we can group them. Seems like some are about accountability, some about figuring things out, forensics, and planning.
That's a good way to look at it. Let's start with the basics, a baseline in forensics. You know, the old saying, can't manage what you don't measure.
Right. So, driver 1, establishing a baseline of exposure. Know what's normal before you start. Makes sense. If you don't know the background lead level in the soil, how can you tell if your factory added any?
Exactly. And that directly feeds into number 2, correlating monitoring data with a suspected source of contamination. This is the detective work, the forensics. If pollution pops up, you need the data trail to pinpoint the source, that specific pipe, that smokestack, maybe even that farm field.
And related to that is driver 6, knowing the nature and degree of pollution from various sources. Is it airborne dust? Is it heavy metals in the water? Knowing what you're dealing with is key.
Definitely. Now, let's shift to accountability and compliance. This is a huge driver for industry, obviously.
Yeah, keeping the regulators happy.
Pretty much. Objective 8 is central here, demonstrating that environment quality is consistently within specified levels. This is Compliance 101, showing you meet the legal limits.
But just hitting the minimum isn't really managing, is it? So driver 4 seems important, confirming and reconfirming the success of pollution control measures. Did that filter you installed actually work?
Precisely. And does it keep working? This is where self-reporting gets tricky. It's easy for a new piece of equipment to work well initially, but does its performance drop off after 6 months because of poor maintenance? Consistent monitoring is the proof that the control measure is actually effective over time, not just installed.
Driver 9 kind of closes that loop, recommending improvements to mitigation measures already undertaken. So it's not just, are we legal, but can we do better? Continuous improvement.
Exactly. It pushes beyond bare minimum compliance. Then there's the planning and prevention group, looking ahead.
Right. Driver 3, estimating the change in levels of pollutants over time, tracking trends. Are things getting better or worse?
Which lets you predict potential future problems, hopefully avoid a crisis.
And driver 7 makes that prediction useful, preventing future contamination by detecting adverse trends. If that trend line is creeping up towards the limit.
You need a plan before you cross it. That's proactive monitoring.
Okay. And the last one, driver 5, makes it economically relevant, aiding in industrial planning by collecting meaningful and relevant information.
Yeah. If you want to expand your factory, you need to know if the local environment can actually handle the extra load. Can the river take more discharge? Can the air absorb more emissions? Good data informs smart, sustainable growth.
So these 9 drivers really nail it down. EM isn't just a regulatory chore. It's this core function linking environmental compliance to actual measurable actions, a management tool.
Absolutely. That's the system. Now, maybe we should shift from the mechanics to the risk it's all trying to manage, environmental exposure.
Yeah, good transition. If EM goes wrong, this is what happens. So define environmental exposure for us.
Okay. The source defines it as having contact with chemical, biological, or physical substances. And these are substances found in, well, everywhere. Air, water, food, soil. The key is that they may have a harmful effect on a person's health.
Contact with potentially harmful stuff, it covers everything.
It really does. And it's not just big disasters, like a chemical spill, though that's included.
Right. Most people probably think of those big, obvious events.
But the sources highlight much more common, everyday exposures. Things like physical exposure, UV radiation from the sun, that's one.
Okay.
Then things we breathe in, cigarette smoke, obviously.
Yeah.
But also invisible stuff like radon gas coming up from the ground, or just general air pollution from traffic or industry. Things we might swallow, contaminated food or water, maybe with bacteria, maybe with pesticides, and even stuff we absorb through our skin, certain harmful chemicals. It's everywhere.
So if exposure is kind of constant, what makes the difference between just background contact and actual harm?
That's the critical question, and why the monitoring has to be so focused on quantifying things. The harm isn't automatic. It depends crucially on 3 factors that EM systems try to measure.
Okay. Factor 1, the dose, I assume.
Exactly. The amount of the exposure, how much, the concentration. A tiny bit of something might be fine. A lot is usually not. Factor 2 is the route, the way a person is exposed.
How it gets into your body.
Right. Swallowing something is very different biologically than breathing it in or getting it on your skin. Our bodies react differently depending on the entry point.
And the third one is time. That sounds tricky to measure.
It is how long a person is exposed, the duration. So these three things, amount, pathway, and duration, are the bedrock of risk assessment. They dictate how you design your monitoring program.
And thinking about duration, the health risks mentioned are serious. Lung disease, heart disease, cancer, birth defects, which I guess highlights why distinguishing between acute versus chronic exposure is so important.
Oh, massively important. And it's a real challenge for designing an EM system. Acute exposure that's usually short-term, high-intensity contact, like a sudden leak from a factory, a big pollution event.
Easier to spot, maybe.
Often, yeah. The effects can be quick, localized. Your monitoring system might have alarms set up for those kinds of spikes.
But chronic exposure, that's the slow burn.
It is. It's the long-term, often low-level contact, like maybe living for decades near a plant releasing pollutants that are below the daily acute limit, but they add up. Or living somewhere with slightly elevated arsenic in the groundwater naturally.
The effects take years to show up.
Exactly. They're cumulative, slow, and really hard to definitively link back to one specific source. And that's why establishing that careful, long-term baseline driver one we talked about is absolutely vital. Without decades of reliable data, you can't make that statistical case connecting a chronic exposure to a health outcome years later.
It sounds like the system needs to be designed to, well, not just yell when there's a big spill, but to kind of whisper when a long-term problem might be starting.
That's a good way to put it. It requires real, sustained commitment. Which actually leads us nicely into how the data itself gets handled and interpreted.
Okay, yeah. We know the risks. We know we need rigorous long-term data. But how does a number on a meter in the field actually become, well, a change in company policy? The source has this structure, right? The environmental monitoring stepladder.
Yeah, it's a really useful hierarchy. It shows how value gets added, mostly through human judgment and thinking. As you move up from a raw measurement, there are 6 steps.
6 steps. Okay, step 1 is just doing it. Observation and measurement. Taking the reading, running the test.
Step 2 is what you get immediately. Data.
Yeah.
Just the raw numbers, right? Big spreadsheet full of concentrations, temperatures, whatever, uninterpreted.
Then step 3, we start to make sense of it. Information. We add context. So that number, say 10 parts per million lead, becomes, okay, that's 5 ppm over the legal limit for lead.
Exactly. Now it has meaning relative to a standard. Step 4 is a bigger jump. Knowledge. This is where you integrate and explain why. You don't just know the limit was broken, you figure out the cause. Applying science, applying operational understanding.
Like?
That 10 ppm lead reading happened because the settling pond overflowed when that pump failed during the big rainstorm last Tuesday. You connect the data point to a specific event and mechanism.
Got it. And stage 5 requires even broader thinking, understanding.
Right. This is about seeing the connections across the whole system. You realize that pump failure wasn't just a one-off mechanical issue. Maybe it's part of a pattern, a systemic problem with maintenance funding, or with how infrastructure is prioritized in the budget.
Seeing the bigger picture.
Exactly.
Yeah.
And finally, stage 6, the top of the ladder, wisdom. This needs real judgment. It's synthesizing everything that came before to figure out the best path forward. Wisdom isn't just knowing the pump broke and needs replacing.
What is it then? What does wisdom look like in practice here?
Well, in the pump example, wisdom means recognizing that just replacing the pump fixes maybe 10% of the real problem. The wise decision maker asks, okay, how do we fix the underlying budget issue? How do we get management buy-in for sustained maintenance? How do we deal with the regulator about this lead spike? How do we handle the potential bad press? And how do we make sure whatever solution we choose is actually affordable and sustainable for the next 10 years? It's blending the technical fix with the financial, political, and communication realities.
Oh, okay.
It's definitely the stage that adds the most human value.
Which makes sense because the source mentions this dual scale on the ladder. Value goes up, but so does increasing subjectivity. The measurement itself is objective, but deciding the wisest course involves making judgment calls on priorities.
Absolutely. And if we want good quality at the bottom of that ladder with the data, we need to be really clear on our terms. The sources point out some important distinctions in language. Well, just basics. Measurement is often just called observation. And the thing we collect is usually called a sample, a small part representing a whole. But then in statistics, sample size means the number of measurements you took. So a bit of potential confusion there.
Okay.
And observation itself, like just looking at water clarity or taking a photo that's kind of non-invasive sampling, you're gathering data without physically taking a piece of the environment away.
Gotcha. Now, what about this distinction between sample and specimen? You said that was crucial.
It really is for scientific accuracy. It's easy to mix them up. Think of it like this. A sample is a part taken to represent the whole. Its quality is supposed to tell you something about the quality of the larger thing it came from.
Like that quart of river water representing the river's oxygen level?
Exactly. That quart is a sample. Its job is to stand in for the whole river at that spot at that time.
Okay, so what's a specimen then?
A specimen is more like an individual example that represents a class or type of thing.
An example.
Yeah. So if a scientist collects a specific fish, say one particular endangered catfish from that same river, and tests its tissue for mercury, that individual fish is a specimen. It serves as an example to provide evidence about mercury accumulation in that type of fish, that species, in that river.
Okay. So sample represents the general environment. Specimen represents a specific type of thing within it?
Basically, yes. And mixing them up in reports, saying your water sample showed high mercury when you actually tested a fish specimen. That leads to totally wrong conclusions about the overall water quality versus bioaccumulation in the food chain. It matters.
It definitely matters. Okay, so we've got the goals, the risks, the data journey. Now, the really complex part. Implementation. How does a big company or a government agency actually build and operate this whole monitoring framework? This is the self-monitoring system, the SMS, right?
Right. The SMS is the operational blueprint, and it doesn't start with buying equipment. It starts with principles, intentions. The source lays out 9 principles for building an SMS. These are like the foundational beliefs for the system.
Okay, let's touch on those. The first ones seem to be about getting the organization on board. Principle 1. Commitment and responsibility. Needs to come from the top, right?
Absolutely. If leadership isn't behind it, forget it. It won't have teeth.
And commitment alone isn't enough if it's stuck in a silo. Principle 2, integration. The SMS has to link up with everything else the organization does, safety, maintenance, budgets.
Yeah. If the environmental monitoring is just some separate checklist that everyone hates doing, it's doomed to fail. It needs to be part of the operational fabric.
Then there's this tension. Principle 3 is exhaustiveness. Cover everything relevant. Don't miss potential impacts.
But Principle 4 immediately follows with simplicity, reliability, and feasibility.
Yeah, the classic conflict. How do you make something truly exhaustive, but also simple, reliable, and affordable?
That's the art of designing a good SMS, isn't it? Finding that practical balance without cutting corners on the science.
Then thinking long-term. Principle 5 is sustainability. You need the resources, money, people, tech, to keep it running basically forever, especially for that chronic exposure stuff.
And Principle 6, continuity. No big gaps in the data. If your monitors are offline for 3 months, you've lost your ability to track those slow-moving trends. That continuity is crucial.
Okay, the last 3 deal with adapting and interacting. 7 is evolution and continual improvement. Things change the environment, technology, laws, so the SMS has to be able to adapt.
8 is about openness, information, and awareness for all. Transparency.
Yeah.
Inside the company, so employees know their roles, but also externally, to build trust with the public and regulators.
Which leads straight to 9, cooperation with the authorities. You have to work with the regulators. It's not an adversarial thing, ideally. Trust and communication are key for compliance, especially for those legal requirements like keeping an environmental register.
Precisely. So the principles set the tone. But what are the actual parts of the SMS? The source lists 8 main elements. The functional components. Think of them as the building blocks you need to define and document.
Okay, building blocks. Element 1 starts with strategy, defining the objectives and results required. What exactly are we trying to achieve with this system? Compliance, improvement, both.
Element 2 is about the people. Organization and share of responsibilities and tasks. Who does what? You need a clear chart from the technician in the field taking the sample right up to the executive responsible for environmental performance.
Then 3 and 4 get into the how. Element 3, planning activities and design of an implementation schedule. You need a project plan, a timeline.
And 4 is the scientific heart. Definition of the parameters and relevant monitored indicators needed to meet those objectives. This is where you get specific. Are we measuring biological oxygen demand in the water? Nitrogen oxides in the air, specific pesticides in the soil? It has to link back to the why.
Then the actual mechanics. Element 5, design of an appropriate measurement and sampling program. Where do we measure? How often? What's the exact procedure for taking that sample correctly?
Element 6 handles the paperwork, essentially.
Yeah.
Data processing and reporting procedures. How does raw data get logged, checked, analyzed, and turned into useful reports for managers and regulators? If this part is messy or unreliable.
The whole thing falls apart before you even get to knowledge on that ladder.
Pretty much. Now, the last two elements might be the toughest to keep going long-term. Element 7 is the action loop, system for follow-up of decisions, actions, and monitoring development. Okay, the data showed a problem. What happens next? This ensures corrective actions are actually assigned, tracked, and checked to see if they worked. Data without action is just data.
Pointless data.
Right. And finally, element 8, the absolute bedrock of credibility, quality assurance and control, QA/QC. This covers everything from handling the sample bottle correctly to the lab methods to calibrating instruments. It ensures that data is scientifically sound, repeatable, defensible.
If your QA/QC is weak,
then all your data is questionable. The whole SMS becomes pretty worthless legally or for making good decisions.
wow. The amount of planning just to get started is huge. The sources even have a checklist for preparation, right? Before you even launch the SMS.
They do. It's the due diligence.
Right.
Step 1, know the rules, description of the regulatory limits for compliance. Get the rulebook out first.
Step 2, look in the mirror. Brief description of the actual situation. What monitoring are you already doing? What equipment do you have? What resources are available now? Assess your starting point.
Step 3, make it concrete, defining objectives and targets with a time frame for implementation. Turn the idea into a real project plan with deadlines.
Step 4 is the mapping. Identification of parameters monitored, location of monitoring points, and preparation of the schedule. The what, where, and when blueprint.
Step 5 is writing the manual. Detailed description of methods and procedures used for everything. Sampling, analysis, calculations, data handling, standardization is key.
And the last bits are about people. Step 6, description of tasks. Who is actually responsible for doing each specific part of those procedures?
And step 7, absolutely crucial. The training program. The best system in the world fails if people don't know how to run it properly. You need solid, ongoing training to make sure everyone follows the procedures, especially the QA/QC standards.
It really is a complete system, designed to shift an organization from just reacting to problems to actually managing environmental performance proactively, all built on data you can trust and a commitment to follow through.
That's the goal, yeah.
Okay, so wrapping up this deep dive, it's clear environmental monitoring isn't a simple task. It's this continuous demanding cycle. We defined its purpose tracking both natural changes and our human impact.
Yeah.
We looked at the risks, especially that tough challenge of tracking chronic low-level exposure.
Yeah.
Then we climbed that ladder: observation, data, information, knowledge, understanding, and finally, wisdom. Seeing how raw data needs careful synthesis to become useful.
And we finished by really unpacking the machinery needed to make it happen. The self-monitoring system, the SMS, those 9 principles for organizational mindset, and the 8 practical elements that need to be built and maintained. It's obvious why the sources kept linking effective EM to a successful overall environmental management system, or EMS.
Right, you can't really manage the environment without that constant feedback loop from monitoring.
Exactly.
So what does this all mean for you listening? Well, it means real environmental protection isn't just about ticking boxes for a regulator. It demands embedding this whole process, from sample to wisdom, deep within an organization's culture and operations. It takes rigor, training, and frankly, resources.
And for our final thought today, let's make it practical. The sources mentioned real-world laws, like Egypt's Environmental Law 41994. It mandates that industrial facilities keep an environmental register. Basically, a formal record capturing the monitoring results. So put yourself in the shoes of an environmental manager at, say, a big oil and gas facility. Thinking about everything we've discussed, what specific things would need to go into that mandatory legal register? What parameters, how often, what follow-up actions when limits are hit?
And maybe more importantly, looking at those 8 core elements of the SMS we discussed. Which one do you think would be the absolute hardest to keep funded and functioning effectively year after year, especially once the initial pressure of setting it up or the last inspection fades away? Is it maintaining that rigorous QA/QC? Or maybe ensuring that follow-up action system actually has teeth?
Where that long-term focus and funding goes,
Yeah.
that often decides if a company truly achieves environmental wisdom or just stays stuck at basic compliance.
Something to think about. Thanks for joining us on The Deep Dive.